Hi guys, welcome to my channel. So in this video, I am gonna discuss pseudo force, how pseudo force are connected in different systems. When we discuss about Newton's laws of motion, so most of the students get confused about pseudo force. So let's take an example how when a pseudo force type of questions is asked, so how to handle them. So for example. I considered that a plank and box problem. For example, this is a plank and this is placed on the ground and there is a block on this. So, for example, this plank is moving with velocity v. So, what will happen? For example, this block when also I am also considering that there is a force Ft is acting on this block. So, we have considered that the plank is moving to the right with velocity v, and initially from the physical point of view, initially the this block will be moving along with this, but this happens because of there is a contact force. I already have discussed there are two contact force, one is normal reaction and another one is a frictional force. So if I zoom out this region, here is a box and I am considered this is a plank. So this area is the contact between the box and the plank. So in this contact region, so for box, if I consider for box, there will be normal reaction N1. But in the same way, if I consider for plank case, so there will be a normal reaction for N2. This N2, this N2 is the normal reaction obtained from N1 because they are in contact. So two surfaces, the surfaces of the block small n and surface of plank capital N. So two surfaces are there. So two surfaces are in contact. So normal reactions will be obtained from two surfaces. For block, for this block, the normal reaction will be from surface of capital M or plank, or for plank case, the normal reaction will be from the from the surface, from the surface of the small m. I mean this one. So there are two surfaces. One normal reaction will be from this one and another will be from this one. So this I am talking about, this is N1 and this is N2. And there will be another so I have discussed these are the normal reaction. Then there is another force that is called frictional force. Friction, which acts parallel to the surface. Here I discussed that normal reactions means normal means the forces those are perpendicular to these surfaces. So, for example, if here I am considering there is a force F, so I am applying force on this body. So the body will try to move right, but there is the internal force, frictional force, that is acting in between. So for example, this is the case of small m, I mean block, and this is the capital M, I mean plank. So in this case I found that when body tries to move right, then the friction, there will be frictional force small f, that will upwards. For example, I so there will be a frictional force. So this frictional force For example, if I erase this one, okay, so there will be a frictional force on this body. There will be on this body due to flank. This, so frictional force from this flank will, because there will be a contact between them. There will be a contact between them. So because of contact, there will be a force along this. So here I am considering that when a force is applied on the body, here I am considering the force is applied on this block, so friction will be backward, because here body will try to this block will try to move forward, but the friction arising from the surface too, the friction arising from this flank, because of they are in contact, will try to oppose, so there will be friction. Similarly, I can for a flank case, there will be friction from here, this here, because here two forces. For example, if I consider this is F1 and this is F2, so these two will be same because they are in contact. So here it will have F1 is equal to M F2 and N1 is equal to N2, because only two surfaces are involved. So it will give f1 is equal to f2 and n1 is equal to n2. So what is f? For example, if I consider from the definition that there is a block and there is a friction acting between. So from the definition, it says that this frictional force is proportional to, if I consider this is a normal reaction, this is proportional to normal reaction. So F is equal to mu n. So here it will be small m. I can directly write small m mu times n, because this is n1. Or n1 is nothing but our n1 is nothing but our, for example, for this case, block case, there will be another force, due to gravity. This is mg, so n1 is our mg. So I will directly write this is mg. So frictional force we already know. So let us talk about, let's draw our free body diagram. This what's our flank and this what's our block. So how many forces are acting on this block? One force is the external force capital F, and I also found that there is a frictional force acting in between, and direction of friction will be backward, because when this force is applied to this block, this block will try to move forward. So to oppose the motion of this block, there will be a frictional force that opposes the motion of this block. So for block for block, I am consider the mass of the block is small m. So I will simply write that capital A minus small m is equal to mg. This is our, this should be our small m. So next thing is that, for if I draw the, for second case, for plant case, what I will write, so I will write, see, there will be a frictional force F, so that F1 plus F2 will be 0. It should be remembered that net internal force should be 0, should be 0. For this I can write this is always be 0, because see here the frictional force arising from the surface 2, I mean surface of the plant, will oppose the motion of this block. In the same way, this plank will experience a force from the surface of this block. So this friction will try to move the plank forward. So the frictional force for this plank will be forward. So I can write the frictional force F is equal to, this should be capital M. So capital M, and this should be, I write wrong one. This should be, I'm considering this is A1 and this is A2. So I have obtained two equations. Then third equation is small f is equal to, I am considered what? Small f is small m mu g. So from here I can calculate what will be the A1 will be what? A1 will be capital M minus uh, small m mu g by small m. So in this way I can calculate similarly for A2 also. If there is a question slightly changed, for example, uh, if it says like F is equal to K times T, in this case, what I am seeing? I am seeing that the applied force, this applied force is gradually increasing. So at a certain time, what I will see? Let's see the what is going on inside. So I am considered at t is equal to 0. At t is equal to 0, our plank was moving in this fashion. Uh, the body was moving with uniform velocity v. So initially, what will happen? The frictional force, the frictional force will try to move. There is a friction between block and this one. I am considered this is capital M. So in this case, I will write that, for example, there is a block. This is a surface and there is a block. And friction, now I am pulling this one by force F, and there is acting another force that is small f. So this force is acting on this block. So I will simply write that the block will move, the block will move. For example, this I am writing, this is a kt, will move, the block will move only if applied force F is capital F is greater than small f. So I will write that F is what? F is Kt, and small f I already discussed. This is a normal reaction. This is a, for example, I am considering this is this block has mass m. So I will write Kt is greater than mu mg. This is the frictional force. So at critical case, so I will write T is greater than mu mg by K. But there will be a certain condition at t is equal to 0, as all are positive quantity. So the block will not move. This indicates that block will not, at t is equal to 0. What will happen? The t is, so all these quantity, this is the f is less than 0. This is meaningless. So block will not move. I will simply write block will not move. So condition is that for, so I will write that After T is equal to T naught, body will move. Body will move. So I will simply write what can I write? T naught will be is equal to mu mg by K. So after this time the block will start to move. So after I can write after this time the block will start to move. So in the previous question, in this question, I already said this question confusion will be removed. I think so after this discussion. So here I simply I can write here we had initially. So there will be from the above discussion I came to know that there will be a certain time. There will be a certain time after which they start to move. So I will simply write drawing the diagram again. This was our small m and this was our capital M. So I will write there will be a certain time. Here I consider that f there is a force acting on this f on this block. So f is equal to kt. So I will simply write that and there will be a certain time. There will be a certain time after which blocks move start to move. So I am considering that t less than t naught case. So both block will move together. So what will be our equation of motion? Our equation of motion will be, for example, if I want to calculate acceleration of both, is I am writing a1 is equal to a2. So I will simply write net external force divided by capital mass, total mass. So here I have discussed that the net internal force is zero. That's why I am considering this external force only. So next external force is our capital M, and net force is our small m plus capital M, and this was our KT. So I already have discussed that there will be a certain time. So if I see here at t is equal to t naught, so acceleration is equal to kt naught by small m capital M. So from here and in this situation also, I will see that the concept behind this type of discussion is that the body will not move because for t less than t naught, I will find that the frictional force acting is less than mu mg. When so if this condition and this condition is satisfied, so block will not move. So I will write Planck and block will move together. But when at t is equal to 0, at t is equal to 0, t is equal to t no. So in this case, what will happen? In this case, our frictional force F will be directly mu mg and T will be equal to T naught. So I will simply write that so external force F is equal to small f. So simply I will write that This is kt naught, and small f is nothing but our mu mg. So t naught I will get is mu mg by t naught. Mu mg by k I will simply write. So after this time, the both the block will start to move. I mean a1 not equal to a2 if t is greater than t naught, and a1 is equal to a2 if t is it's less than or equal to t naught. So this condition should be satisfied. So we have already discussed after t naught. So how acceleration will be calculated here? I am calculated in this fashion, and similarly I will calculate it too. So let us discuss about new topic. Our new topic is for example, from the mass pulley system. I always consider that pulley there will be no slipping case. No slipping I was already considering. If you forget, I am just remembering. I will uh, recall, for example, what we had already chosen for a ideal pulley. So for a ideal pulley, I considered that pulley should be massless. I was considering this should be a massless. Second was non-rotating, and third case I assumed that in the previous video. So this was no sleeping cases I considered. So for example, no sleeping case, this means that there exists friction, there exists friction in between string and the pulley. So this must be satisfied, otherwise there will be slipping. So there must be a friction. So for example, if I consider this pulley and ropes goes in this fashion. So for example, the ropes makes angle theta with each other. For example, this is a T1 and this is T2. So in this case, what will be the relation? I want to know what will be the relation between T1 and T2. So in this case, I will simply write for T2 greater than T1. T2 greater than T1. So I will simply write T2 is equal to T1 multiplied by E to E times mu theta. What is mu? Mu is our coefficient coefficient of friction. Friction, I will write this is a coefficient of friction between the rope and the pulley. So this is the relation among T1 and T2. So for example, a question can be asked like this is a cylinder and a wire is, for example, a wire is wounded around this cylinder in this fashion, and there is a capital if for example this is I am considered this is a mass of 2 kg. 2 kg, so this is 2 m1g, and this is m2g, and m1 I am considering this is 1g, and m2 I am considering 2 kg. So definitely I can see, for example, if I consider this is a T1 and this is T2. So from here I directly can write that T2 is greater than T1, because T2 is what? T2 is T2. For example, in this direction, this will be M2G, this will be M1G. So tension will be upward for this case. So T2 will be simply 2G, and T1 will be just G. G means our gravity 9.8, now 9.8 meter per second square. This you so usually everyone knows. So I will simply just put T2 here. I found that T2 is equal to 2G and T1 is equal to 1G. So from here, from the above relation, I know that T2 is equal to T1 E times mu G, sorry, mu theta. So what is theta? So if I consider here, from here to here, this is just 2 pi rotation. From here to here, this is just 2 pi rotation, 2 pi angle. And from here to here, up to here, because after this will not touch. And similarly for this, here to here. So here to here is pi by 2, and from here to here, this is pi by 2. So total contact is theta is equal to 2 pi plus 2 pi plus pi by 2 plus pi by 2. So this is 5 pi. I find that theta is 5 pi. So I will directly put here. So this is 2g is equal to 1g e to the power 5 pi. So g will be cancelled out. So 5 pi mu. So 5 pi mu will be ln2. This will be ln2. So mu I can calculate from here that this. Now let us discuss the next problem. Next type of problem can be asked related to friction. So frictional. So I will consider here in the above problem I consider only two blocks. Only two blocks. One, this was the first block and this was the second block. So let us discuss some general problems. For example, there are three systems, three blocks are loaded on above each other. So, for example, if I consider the mass of above one is m1 and the middle one is m2 and lower one is the m3. So I will directly. So, for example, if there is a force acting on the on upper one, so question can be asked, what will be the friction in between, and what will be the acceleration if I am considering the acceleration of first one is A1, second one is A2, and third one is A3. We have to find out those, how to deal with them. So first approach will be our for example, first I will assume that all the forces, for example, uh, here I will collectively choose that the block will move together. The block, all the blocks move together. So there will be no internal forces, because net internal force will cancel out. So there will be only external force and all the blocks will move together. So in this case, acceleration A1 equal to A2 is equal to A3. Here, what I consider all move together. So I will calculate for this is the external force F is equal to m1 plus m2 plus m3 from the equation of motion. So I will simply write A is equal to capital F small m1 plus m2 plus m3. So from here I found what will be the isolation. For example, if here I am considering the frictional coefficient as m1 and this is as m2. So for the from if I see this clearly, draw this one, then this is there is another block one. For better understanding, I have drawn all the diagrams clearly. So here, for example, see here I am applying a force on this block. Okay, so on this block I am applying the force. So this block will try to move forward, but but the frictional force in between will oppose. So on this block the frictional force will be backward. But if I consider that what will be happen, then frictional force on this block due to this one will be forward F1 and I am considering this F1 because there is a contact in between. So the frictional force help will help in moving this block and will oppose the motion of this block. This one I consider this one as M1 and this one as M2 and this one as M3. And in this case, I don't know what will be the direction of frictional friction F. I have just considered this as F2 and this is F. So if I write equation of motion for first block, it will be just F minus small f1 is equal to m1 a1 m1a because I consider that all the blocks are moving together, so all the blocks will have a common acceleration. So from here I can calculate uh, a will be now sorry uh, a I know already, so I want to know what will be the f1. So f1 I simply write f minus m1a, and I have already calculated here what will be a. So I will directly can write this will be m1 will be cancelled out. So this will be m2 plus m3 times a divided by total mass m1 m2 plus m3. Then I will check. Then I will check whether it is uh, whether it is less than or equal to m1 mu 1 g. I have to check this condition. If this condition is satisfied, then I will come to know that m1 then m1 and m2 move together. Otherwise, this motion is not possible. But if this condition is satisfied, m1 mu 1g, then I will simply write sorry, this equality sign should be dropped here. So m1 and m2 will not move together. So I have to consider that a1 is not equal to a2 in this. Similarly for the second case, uh, if I draw the free body diagram for this case for m2, I will just write f1 plus f2 is equal to m2a, and I already know what is f1. From F1 I know what will be the F1, and I have to just calculate what will be the F2. So F2 will be M2A minus F F1, sorry, this will be F1. So I will just write M2A minus F1. I already calculated. F1 is M2 plus M3, M2F minus M3F. This was whole mass times acceleration. So what I found? I found here that this will be a negative M3F by M1 plus M2 plus M3 times. What negative sign indicates? The negative sign indicates that we have to take F2 direction is in the opposite direction. We have to take the direction of in the opposite direction. Now, then I have to check. I have to match this relation that this should be less than this should be. I mean the magnitude in magnitude wise. So this should be less than mu2 times m1 plus m2. M1 comes from the upper block, so this is the N2, and we know already that how to calculate a normal forces in between. So I uh, I just inserted just N2 here. So I have to check this one. If this relation is satisfied, then I will call. I will say that three now block M2 and M3 move together. Otherwise, the motion will not be possible. So in this way, if there are many blocks, for example, there are three blocks, there are four blocks, problems I can calculate. For example, there is four blocks, then I can calculate what will be the friction, what will be the A1, A2, A3, and therefore can be calculated in this fashion. So let us jump into the spring force. I will just give the introductory case spring force. I am assuming that you must have some basic knowledge about spring force. So I will not elaborately discuss what is spring force, where it comes from. So I will not discuss. So for example, we have a spring connected to a block, then the block, then there will be a tension. For example, yeah, this is initial condition, and I consider that there is no extension. I'm assuming the extension or compression is zero, so the system is at rest. So if I put some impulse, the body will try to move right, then extension will increase. The extension will increase, then there will be opposition force, that will called F del x, that will oppose the motion of the body. So I will simply write that F is equal to minus K del x. So this is the principle behind the spring. So if I found there are many springs, so I will discuss two cases, two special cases. One is the parallel case and another is the series case. So parallel case means there are many springs, they are connected in parallel in this fashion. For example, in this fashion there are many springs are connected to a block. I am considering this one. This is a spring constant K1 and this is a spring constant K2, and the lower one has spring constant K3. So in this case, this is the parallel one. So parallel one, for parallel case, so I will just simply write this is the Kp, means the net, or I can write effective value of the combination. This will simply just k1 plus k2 plus k3. Or if there is more than three cases, then I will just write ki. I will just add all the values. Similarly, in second case, if there is a spring, for example, this is connected to a wall. There are many springs. This is K1, this is K2, and this is K3. So in this case, I just uh, take K series equal to summation over 1 by K. So this is the effective formula. If there are more than one spring, how to calculate them? Also, for example, in discuss the important cases. Case 3. For example, there is a spring. This is the spring I made. For example, in this has a length L. This has a length L, and I just got in the middle, and I'm considering, for example, this one has length L1 and this has length L2. So total spring constant had value K, but after cutting this, the new will be what will the question can be asked like what will be the new spring constant of this part. We should remember that the spring constant for a particular spring, the multiplication between their spring constant and its length are constant. We should remember this formula for this case. So I will write KL is equal to K1 L1 equal to K2 L2. So from here I can calculate what will be the K1 and K2 directly from this relation. So this was all about today's class. I'm ending this the lecture. So I will continue from tomorrow. Okay, bye.